Great. Welcome, everybody. It is a great pleasure to welcome you all for the kickoff event for Advanced Air Mobility Supply Chain Working Group. With us, we have Dana Jensen, who is my counterpart at DoD, who will be co-leading this work group. And Dana and I will be basically looking forward to work with you all on this important topic to make sure that we have a really solid, resilient, robust supply chain that will scale the operations for future. Dana is a senior policy analyst at DoD's Agility Prime as well as Office of Commercial and Economic Analysis. So we look forward to continue the discussion, but this is just the beginning. So next slide, please. Dana, would you like to offer any welcome remarks before we go to this slide?
Well, certainly, and I appreciate the invitation to co-lead the working group. This is an exciting time in aerospace to see the birth of a new ecosystem and to have the opportunity to wrap our arms around an emerging supply chain as it comes together. That will allow us, I hope, to kind of foster efficiency and competition and health at the very base levels, all the way down to the raw material side. So, very, very happy to be involved and looking forward to our meetings over the next few months.
Awesome. Thank you, Dana. So this is today's agenda for everybody's benefit. So we will have number of initial opening remarks from NASA executives, FAA executives, and DoD executives. Then Dana and I'll make a brief presentation of what we view as the initial need and how the approach is going to work. And of course, we look forward to your comments, and we need your comments and feedback so we can make this much more richer and more impactful. We are doing this collectively for the benefit of industry and ecosystem for advanced air mobility. So it's only as powerful as we collaborate and create collaborative innovation. We will also be taking Q&A towards the end. Through the conference IO, that information will be made available as we go along, and then we'll talk next steps. Next slide, please. So here is the information for offering questions on arc.cnf.io. If you go to that on your browser and you click on AAM Supply Chain Working Group Kickoff, you will be able to participate and provide questions that we will answer. If we can't answer all questions today, we will take note to take them to answer them in writing or the next time we meet. We are going to meet fairly regularly, so we will be talking about that. Next slide, please. So this is just the kickoff, as I mentioned. So there is a lot of dialogue and opening remarks, as well as perspectives and our vision. But that is just the beginning. The subsequent meetings are a lot more interactive and much more integrated with audience participation and you all. We have tremendous interest from industry, everybody that I've talked to and who have given us responses to DoD as well as NASA through our request for information and Agility Prime's website. We have over 400 respondents, and we are looking forward to working with you all. This just shows the importance of this topic. And as of even yesterday night, I was talking to a bunch of folks who were sort of articulating why they are so interested and in making sure that the supply chain aspects are addressed properly for a variety of systems and subsystems all the way to raw material, as Dana was talking about. So next time we meet on September, we will be talking about the current status, state of the art on drones and eVTOLs and the challenges these particular industry members have. So we want to hear from you Of course, you don't need to share any proprietary information, but generic information that is pertinent to building the ecosystem that will support you. Then we start to look into the tiers, setting up the right tiers in October, identifying where standardization is useful so that it cuts down cost, increases the throughput and such. Ease of maintenance is also offered through many standardization practices. Then we will look at the electronic platform requirements. We are beginning to build that. We'll talk about that. And then the overall modeling environment to analyze the overall status, health, and future needs of the supply chain. You can always provide us feedback asynchronously at this email below. Anytime you have a comment, question, feedback as to how the working group should be run, or the topics or the contents, or if you want to participate, please provide us feedback. This is, as I mentioned, much more participatory and engagement-oriented kind of dialogue as well as interaction. So please send us your feedback to make this better. This is all about collaboration here. Next slide, please. So here are a couple of names that you could find useful in case you need to contact for logistics as well as overall organization and management. Anna Kowalowski and Brian Stallsmith, those emails are there. Dana and I are the technical points of contact, so you can always contact us for your thoughts, and you can email that generic email address every time you have a suggestion, so it gets captured in a way, and we check that routinely, as well as you visit the website we have that's focused on the advanced air mobility supply chain. And we'll, of course, going to see you on September 10th. So, and can we go back to the welcome slide, agenda slide here. Thank you. Next, okay, perfect. So now I would like to introduce, without further delay, I would like to introduce John Montgomery, who is Deputy Associate Administrator for Policy at NASA Aeronautics. It's a great pleasure to have him and other executives that we will be introducing as we go along to talk about the importance of supply chain and how we want to work collaboratively with other government agencies as well as industry at large. So please welcome John Montgomery. Thank you, John, for joining us today.
Thank you, PK. Thank you, everyone. Can you hear me okay?
Yes.
Okay, very good. I'd like to add my thanks to and welcome to the workshop today. PK offered me the opportunity to provide a few opening thoughts, and so I'll do that and pass that on to some colleagues who have additional things that they can share. From my perspective, I just wanted to talk a little bit about strategy and how this fits into our efforts and why we're doing this. So the NASA Aeronautics Research Mission Directorate's strategy is to advance state-of-the-art in civil aerospace technology to enable the transformation of global aviation. And technology leadership fostered by NASA is the key to U.S. preeminence in aerospace manufacturing. And our strategy is built around three drivers, including growing demand for mobility of all types, ensuring sustainability, and the convergence of technology and harnessing that technology across multiple sectors. Historically, this very strong growth in aviation that we have been blessed with is directly tied to growth in wealth or GDP. And in turn, strong growth in aviation translates to high-paying, high-skilled jobs in aerospace manufacturing sector with the largest U.S. trade surplus. And aerospace manufacturing goes beyond our major OEMs, Boeing, GE, Pratt & Whitney. It consists of thousands of suppliers as well, who provide parts, systems, and materials to meet this need. And a strong, sustainable, and scalable supply chain is critical to the health of our aerospace industry. I know from at least my vantage point how hard it is for these small suppliers to break into the market and then to succeed. One of my first jobs early in my career at the U.S. Department of Commerce was supporting U.S. aerospace manufacturers seeking to build their business internationally through trade missions and trade shows, and saw firsthand what those challenges are. Through this workshop, we're interested in understanding how we might foster U.S. technology leadership in this particular aspect of the aerospace industry and supply chain. In particular, we're seeking to better understand industry and government needs for a robust and resilient supply chain ecosystem for emerging air vehicles. And that supply chain includes all aspects, including access to talent and skills from design, manufacturing, and repair. We're engaging in the conversation on supply chain development through collaboration across many government organizations, industry, academia, regional and local organizations. I'm very pleased that we have several of you here today to be part of this conversation. NASA's supporting role is focused on identifying future needs, assessing challenges, and doing our part to foster a strong and resilient aerospace supplier ecosystem. This is a little different than our traditional research. To kickstart us internally, we've started a small effort using the Minority University Research and Education Program to identify those supply chain needs through some focused research. And NASA is considering what role we might play in developing modeling and simulation capability and assessing future scenarios to ensure that supply chain resiliency and strength, as well as preparedness to support different air vehicles and their production targets. We've all seen the value of the supply chain and the challenges that they're facing along with the overall aerospace industry during COVID impacted scenarios. And it's really critical that our aeronautics supply chain remains strong and that we have come out this current pandemic stronger than we were going in. It's tough, but we are seeking to make a difference where we can. And so therefore, we're looking forward to continued collaboration through these workshops. So with that, let me pass the ball to my colleague, Ed Wagner. He is Deputy Associate Administrator for Programs for Aeronautics Research at headquarters. And Ed, over to you.
Okay, John, thanks a lot. Appreciate those words. I also want to add my welcome to all the participants, but I particularly want to thank PK and Dana and Anna and Brianne, the whole team for putting this together. There's just so much behind the scenes work that goes into something like this, and it's often, just kind of passed over, that you snap your fingers and it happens. But we know that a lot goes into this. So PK and I tag up pretty much every week to kind of discuss some of the key topics and challenges du jour. And when PK first started seriously talking about supply chain, I totally didn't get it. I didn't understand the issues or what he was talking about. But as we marched along and PK started to kind of educate me and explain the components and the various challenges of efficient integration and the myriad of potential stumbling blocks, I started to kind of get the flick, so to speak, and understand the system required to start with just raw materials and components and then turn those into real products in the consumer's hands, and to do this in as efficient manner as possible. So that's the supply chain. And then the overall efficiency of how well a company can do this, to me, that's kind of a key parameter in their profit equation. And of course, that translates into viability and jobs and all the things that John was just talking about. So as I kind of thought about this, I could identify supply chain issues, even though I didn't know that that's what they were, over the past half a dozen decades that I was familiar with. And I'm not going to go through all this to tell you exactly how old I am, but even back in my early teens, there was this sexy new Ford Mustang that came out, and to try to get a convertible in either midnight blue or canary yellow was next to impossible. And then these kind of things continue right up to the present, looking at issues of having sufficient ventilators and critical care units to deal with the COVID-19 crisis in the U.S., much less worldwide, are things that we've all just recently seen. Okay, so now I'm beginning to understand this whole supply chain, but I still had some issues in, okay, what does that mean to NASA Aeronautics? How does that affect us? And so we talked about that a good bit too, but aerospace supply chain is critical. Back prior to the MAX issues, our friends at Boeing were on an arc to expand their 737 production lines to near 100 aircraft a month. And so supply chain and associated concerns were embedded in any of the decisions of suppliers and components that were necessary to increase to those production levels. And of course, that extends from these production rates for current aircraft to enabling growth and profitable production rates that are consistent with what we're now going to see as a new demand curve once the COVID situation has subsided somewhat. And then supply chain and the management of the supply chain is critical for new types of aircraft to ensure future needs are being met. So we've even seen that in issues associated with the flight demonstrator development projects that we have going on in NASA Aeronautics. But in the design stage through build and assembly, all the way through rollout, the time required for each phase is vitally important, hugely dependent on supply chain. And reliable access to suppliers for both raw materials and specialized parts, subsystems, and the talents and the skills of the folks that are doing the work. These are all critical parts of the supply chain. So I'm going to talk just real quickly, just a couple of experiences that we've seen recently in our developmental programs. Directly here in NASA Aeronautics, we're making great progress on the low boom subsonic demonstrator, but we're seeing that dependency on a strong, robust supply chain is being a huge part of the progress that we're making. I mean, going to signing off of drawings, getting those drawings to suppliers, small batch production, one-off kind of parts and components, and new production and manufacturing techniques, for example, robotic drilling and riveting. All of these have afforded significant challenges in building this demonstrator. Other examples we've seen in our X-57 developmental program, where we have examples of limited access to suppliers who can really provide the specialty parts that we needed. A prime example of this is the electric motors that we needed for X-57. We started testing the motors that we had, started having some issues with reliability, robustness. So we broke down those motors, and what we could plainly see were these were really not production quality motors that we thought we were getting. Another prime example has pesky off-the-shelf battery system that we thought we could procure for the X-57. We started testing these batteries and immediately had a huge problem. Our engineers on the X-57 team referred to this as a rather benign sounding thermal runaway, but I saw the video, and for me, seeing that battery catch fire and exploding was pretty darn dramatic. So these issues have now been dealt with. They're kind of behind us. And the resulting outcome is one that we're proud of, particularly relative to the battery issues, and that we now have a commercially available product available with a new distribution system and a way to make this available to our stakeholder community. But our lesson here and what we've dealt with gets to the heart of the supply chain, and for our research team, this resulted in a chaotic situation, significant associated risk, time, and resources that had to be dealt with. So now there's no doubt in my mind that this workshop, the discussions that we're going to have, and the working group that PK and Dana have put forward will help NASA in understanding both the needs and the collaboration that we need to build a strong ecosystem that will benefit our OEMs, suppliers, and researchers. So I'm here and eagerly looking forward to the rest of the day and a great learning experience. So with that, I'm going to turn it over to my colleague, Jimmy Kenyon, who's the Program Director for the Advanced Air Vehicles Program. Jimmy?
Thanks, Ed. And I want to add my thanks to everyone who's joining us today online and who's participating in this really important workshop. And I do want to take a minute and add my thanks to PK and to Dana and to the team that's been coordinating and putting all of this together. Just a great job, and again, a very important event, and I'm so happy to have so many people participating. Here at NASA, I have the privilege of leading the Advanced Air Vehicles program, where we're developing the tools and technologies to enable the next generation of aircraft in all flight regimes, from Mach 0 all the way up to hypersonic. These aircraft, when you look at that portfolio, will ultimately enable people to fly more efficiently, will allow more people to fly more efficiently, more sustainably, faster, and more safely than ever before. So these aircraft really open up new markets. They open up new opportunities for people to connect with other people. But all of these future aircraft, and quite frankly, today's aircraft and their manufacturers, will depend on a robust supply chain for success, starting anywhere from raw materials all the way up to parts manufacturers and going to the finished products coming from the OEMs. Now, prior to the COVID-19 pandemic, our industry was abuzz. Record sales, driving record backlogs, record delivery rates. The supply chain was saturated. It was the best of times, it was the worst of times. Of course, everybody likes having great business. Everybody likes having full backlogs. Everything's good, but in many cases with a very saturated supply chain, it can become very hard to get the materials, to get the parts, to get the supplies that you need. I've spent most of my career in advanced programs and have gone through many of the things that Ed talked about in terms of when you're looking at one-off demonstrators or prototypes, trying to get the parts that you need to get that done can become very hard. So now that's where we were. Of course, things have slowed down with COVID-19, and I don't like predicting the future, but while things have slowed down right now, we would anticipate that at some point, future growth is once again going to drive our industry to capacity. And when that happens, our supply chain will absolutely need to be ready. In addition, of course, to the traditional market and having a very busy traditional market, new markets such as advanced air mobility are emerging that will drive different needs in areas in terms of production rates, materials capabilities, production quality, and so forth. And so, as an example, future electric vertical takeoff and landing aircraft will need to be really lightweight and would potentially require very high rate composite manufacturing to meet production demand. These composites will need to be, of course, at least as lightweight as what we can do today and inexpensive. And yet, so think about the automotive market as a good example of how that would work. And yet they need to be certifiable for flight to carry people in the air. Fuselage, large component manufacturers and suppliers are going to need the tools and the processes and the techniques to meet this design and manufacturing challenge. So in the coming year here at NASA, we're going to launch a new effort in high-rate composite manufacturing that may help. That effort will initially be focused on large structures for traditional large transport aircraft, but many of the tools and processes that we're looking at could potentially be applied to eVTOL aircraft as well. This new project is going to build on our successful advanced composites project that just recently completed in the past year. We wrapped it up after demonstrating successfully a more than 20% reduction in the amount of time it takes to go from a new concept to certified for large composite aircraft structures. Of course, we did that through demonstrating improved life prediction techniques, better, more rapid inspection and characterization techniques, as well as efficient manufacturing processes using process modeling and high degrees of automation. Those same technologies and techniques can also help improve manufacturing rates while ensuring consistent process control and quality, all of which will be needed to have that supply chain ready to go to meet that market demand. So this new effort could create some very interesting opportunities for new entrants in the supply chain or for more traditional suppliers to expand to a new market. As we stand up this new effort, we'll be working with suppliers and leveraging outcomes from workshops such as this to help us understand what tools, technologies, and processes are needed to meet future market demands. And this is just one example. As our industry starts to recover from the impacts of the pandemic and as new markets such as advanced air mobility emerge, we'll need a robust, resilient supply chain in place and ready to go with the right tools, the right talent, and the right capabilities. This workshop and the insight that you'll produce will be very valuable to us in helping us understand these needs and where government innovation and investment can make a difference. So thank you so much again for participating. And with that, I want to hand it off to my colleague and friend, Dr. John Pavlowski, Program Director for the Transformative Aeronautics Concepts Program here at NASA. Thanks.
Jimmy, thank you. Ed and John as well, and PK. Appreciate the opportunity to add my words of welcome to those of my colleagues and provide a little bit of an extended focus on why I believe that this is a critical and valuable opportunity for us with our larger community in order to be able to identify supply chain needs and requirements. The program that I oversee, the Transformative Aeronautics Concepts Program, focuses on investments in future concepts with, as you can imagine from the title, transformative potential. And that potential is applied to not only the ARMD portfolio, trying to find the next thing that folks in Jimmy's program, as an example, can take to look even a step beyond where they are thinking right now, but also to identify activities that can support change, growth, and transformation of our larger aeronautics enterprise. These future concepts, these novel concepts that we take on, they, by definition, they provide unique growth opportunities. And that potential is what we strive for in order to try to transform and provide new markets and new capabilities for value. But as a result of that, they also present challenges to the growth of those markets as new technologies create impediments at times to the supply chains and the ability for those supply chains to support elements of this new growth and new opportunity. I mean, you were hearing Jimmy and Ed and John, all three of them talk about a variety of different areas that we're already seeing some of these things. And those things may be growing more so in the future as we find new applications and new ways to take advantage of more electrified aircraft propulsion systems, novel material systems, whether they be for reasons of thermal insulation around our electrical capabilities or for deployment of smart vortex generators at altitude with shape memory alloys. And certainly, as is the topic of this particular workshop and this endeavor, when we're looking at advanced air mobility and areas of drone work, autonomous operations, both on the technology side and indeed on the talent side that we need in order to make these markets a reality. All of those are challenges to the supply chain that can be generated as a result of new, unique concepts and approaches to our growth in this industry. We learned a lot of this from the early stages as the growth in drones was beginning. Certainly our DoD colleagues, Dana, and the involvement and interest concerns they have here are exacerbated by our drone challenges right now and the need to make sure we have robust U.S. supply chains. But from the perspective of my program and the focus of Transformative Aeronautics Concepts, want to make sure that we are exploring not only these concepts, but the needed supply chain as early stages so that consideration of those needs, the gaps, and the risks related to supply chains can be addressed early in the process. So as we kick this off, you're going to hear from PK about NASA research on some modeling and simulation capabilities that we want to be working very collaboratively with our partners. I mean, DoD initially here, but the expansion of that to others. John mentioned commerce and other capabilities that are going to be important to bring in here. From my view, I want to make sure these future concepts that have new needs in terms of our supply chains and digitized means of coordinating designs and implementation are taken into consideration. So I'm excited about these opportunities, excited to seek to provide elements of investment to make sure that we can do this work early on and ensure that we're ready for that future, whatever form it takes, for value here, U.S. domestic, manufacturing and our capability and our overall aviation growth. So PK, let me not take a lot more time. We have a very interesting discussion agenda going forward. So let me turn it back to you for our next speaker.
Yeah, thank you, John, and thank you, Jimmy, Ed, and John Montgomery. Thank you for your welcoming comments and opening remarks and importance of the supply chain. You set up the stage very beautifully. Thank you for doing that. Now we're moving to our great partner from FAA, Dr. Mike Romnowski, who is known for his pro-innovation stance, and he is director of Policy Innovation Division at Aircraft Certification Service. So please welcome Dr. Romnowski to offer his comments and opening remarks on this topic and FAA's role. Thank you, Mike, for joining us.
Thank you, PK, and thanks for that kind introduction. I really appreciate it. And I also want to thank you, Dana, as well as our NASA colleagues and Nate Diller, who will be joining us later. Thank you as well for your partnership. I really appreciate the opportunity to be here with all of you. This forum is another great example of that strong partnership we have between the FAA and NASA. It's also a great example of the growing partnership we've had with Agility Prime and the Air Force. Stepping back a little bit, one of the things I notice is that when we start talking about emerging areas, whether it's advanced air mobility, the varieties of unmanned systems, high-speed aircraft, a lot of the public and industry focus seems to remain on design certification. And I understand that. However, for any of these areas to be safe and be successful, we need to view the full range of the product life cycle, the design and development, the production, and the vehicle's operation and maintenance as well as its integration into airspace. And overall, that life cycle is what's reflected in the FAA's regulatory safety framework. Pardon me. We have a number of cross-agency partnership activities that are focused on the design development. We also have a lot that's focused on the operations integration. But this initiative, I believe, is the first one where we focused on the production and the supply chain. So I want to thank you guys for your foresight into looking into this. At the FAA, we have a regulatory framework for production quality systems and oversight that's pretty well established. However, I want to emphasize for everyone out there, this doesn't mean that we necessarily have a one-size-fits-all solution across the range of products that we see. The framework, I will confess, can sometimes be overwhelming. There are a number of detailed elements to that framework that make up a tiered system like the one PK referred to in his introductory remarks. We have things like production certificates, or you'll hear the terms PCs, you'll hear technical standards orders or TSOs, you'll hear parts manufacturer approval and PMAs. There's a lot there. I don't intend to go into all of that detail here. We are going to have our folks supporting this initiative that can help inform and educate folks on those structures as we move through this initiative. But for now, for today, I think the thing I want to leave everyone with in terms of where the FAA is we tailor our oversight to risk, okay, both in criticality of the components to the vehicle's safe operation, as well as the risk to the public and passengers for a specific vehicle type, okay? We don't have that one-size-fits-all approach to this. So again, step into what are we looking for in production. The fundamental purpose of our production oversight is to ensure that the aircraft and its components are produced to meet their design intent. Okay, that is, that the aircraft and its parts reflect the design we certified, and that therefore it's a safe product. Okay, So I'm put this into simpler terms. The expectations we have for transport aircraft are far more rigorous than our expectations for experimental aircraft. Passenger carrying vehicles and their parts are going to receive greater scrutiny than small unmanned aircraft operating over fields and forests. Okay, it's fairly straightforward in approach and implementation. So while we're making a large number of allowances for the use of a large number of commercial parts in the certification and production of small drones or unmanned aircraft, that's not going to be the case as we step into advanced air mobility vehicles that are in certification, where we're going to have greater levels of parts traceability and conformity to approved quality systems. So expect to see that as we move forward. And so it'd be important that new companies, both producing the aircraft and the new entrants coming in the supply chain, understand these systems and the expectations, and they understand what they will be facing as they enter the new arena. Now that we're there to assist, so this isn't, it shouldn't be viewed as a daunting proposition, but I think it should be viewed as one where a good deal of education should go into it, and making sure that the assumptions you're making are correct, right? And we stand ready to assist companies as they move into this space. We're currently working with a number of new advanced air mobility manufacturers as they stand up their production systems. We're working with them on the design certification. We're working with them as they're standing up their production systems, as well as their supply chain management, and making sure that they have that laid out in a way that'll meet all the requirements and deliver the safety. We're also working with a number of firms as they explore supplying new systems and components. So we're going to bring that same level of commitment and energy to this supply chain initiative. And again, I really look forward to the partnership with NASA, with the Air Force, and all of you as we move forward. So with that, PK, I'll turn the discussion back over to you. Okay, so thank you very much. Really appreciate it.
For joining us, Mike, and looking forward to having also a co-lead from FAA, as you mentioned. So Dana and I will be joined by someone from FAA as well. So that's going to be another exciting development, and we'll be able to announce that next time we meet in September. So thank you for that, Mike. Our next speaker is Colonel Diller. Nathan Diller is a great friend of industry, as everybody knows, and he is director of AFWorks, as well as you know, Agility Prime, and he has also multiple other engagements at OSTP and such. So please welcome Colonel Diller, a great friend, innovator, a very enthusiastic champion for the industry. So thank you for joining us.
PK, thank you so much. How do you hear?
Very good, thank you.
All right. What a phenomenal effort this is here, and in particular, a phenomenal partnership, both with the FAA, in particular, with all the fantastic things that Mike Romanowski is leading there, certainly with PK and NASA, and from our perspective, work that we are really trying to do with industry. So I'm going to talk just a little bit at the beginning here of AFWorks and this new approach to AFWorks and what we're trying to do. When we look into the future for our national security capabilities, what we see for the Department of Defense is a case where there's just phenomenal work that is happening. This is not necessarily saying that there's not work happening in the Department of Defense, but there's just been this blossoming of technology. And clearly the case study that we'll look at today as it relates to supply chain is the urban air mobility, the advanced air mobility, electric vertical takeoff and landing market that we have been exploring under Agility Prime. And it really represents, we think, a fantastic case study to look at this world now where the commercial sector is bringing forward a fourfold increase in investment in research and development over what we were doing in the Department of Defense in the past. And so as we look to that, As we look to the future and the potential opportunities, the potential risks as well, that future gives us, what we really see is a need to partner, and this is called for very specifically in our national defense strategy, a need to partner in ways that we haven't before. And when we look to AFWERX, the three components that we have as part of AFWERX, the foundation of those three components, first and foremost, is partnership. We think in particular partnership across industry, and in particular partnership in some cases across some of those non-traditional players in industry, where the barriers to entry in many of these tech areas has been radically reduced, whether it be through the things that have happened with software, things that have happened with advanced manufacturing. The ability to quickly enter into this technology sector with relatively low capital has been reduced, and so that need for that industry partnership is different. There's also the need for partnership with investors. We think that there is, moving into this future, a way of partnering with investors that provide a return on investment in ways that maybe they've not considered when we look at the interaction that we've had with federal government. And I think, again, foundation of partnership being key to all of that, in particular the foundation kind of across the interagency of partnership, and that partnership that you're seeing here today. As we look at working with investors, are there ways that we can, in this particular effort with supply chain, identify more clearly those areas where there are gaps, where there are key capabilities that going into a future where, if you look at studies, Morgan Stanley, for example, that in a 2040 world, there's the potential of a $1.5 trillion market in advanced air mobility. How do you start to highlight that early? How do you build that foundation early? And I think that is the foresight that PK has had, is he's established this initiative. And I think it's one now that it's not a conversation and talking about it, but it's actually real action that's being taken. And it's hopefully action that is something that we can communicate to investors, to industry, to do that. The other partnership that we think about is a partnership across the interagency, and that's what you're seeing here today. And so just a fantastic effort, having not spent a significant amount of time working in the interagency and maybe just studying, hearing about it, discussion often of, well, there's these silos and you've got people that are protecting their rice bowls. The group that you see here today has just been fantastic in the level of collaboration that's there. And I think what you're seeing is a coherence in our message of how we collectively are going to work together, whether it be on supply chain, whether it be on testing, whether it be work that we're doing in order to certify future aircraft. That interagency partnership is key. And we see it not only as partnership, but we also see an opportunity. And this goes as the director of AFWERX across multiple different sectors. I think we have the potential to see it here in advanced air mobility, an opportunity to actually start to create a market in some of these higher risk technical areas where we can, from a public use, where we can in some of our ranges, start to reduce that risk and create a market across this interagency group for those early capabilities, so that we are in a very controlled environment, ensuring the safety, ensuring security, again, in those controlled environments that accelerate our commercial capacity in ways that have not been done before. And so to me, that part of being able to build that market is extremely exciting, and it comes through a collaboration across the interagency I haven't seen before, to include some white papers that have been written to describe a variety of different use cases. And then lastly, eventually looking to see how in our global environment, what does it look like to have that partnership across our partners, international partners that are out there. That is certainly a key interest that we have had in Agility Prime. It is part of our national defense strategy, and looking to see what that supply chain looks like. Where are those areas that our international partners can help participate in the resiliency, in the safety security of that supply chain, maybe in ways that we haven't done in the past. And so that last part of that international partnership is certainly key. So again, that foundation for us in AFWERX is that partnership piece. Sitting on that foundation then is making sure as we look to a supply chain, we look as we're looking at ways of accessing this future technology in the commercial sector, again, in this eVTOL sector where commercial certainly led, right? This was not a DoD-led effort. You can certainly see some value that DoD has brought in some component technologies. Certainly GPS is going to be key. GPS independent navigation is also going to be key. Both of those being key DoD investments. Autonomy into the future, a series of programs across the Department of Defense that have been and continue to be run in that, as well as manufacturing. But it was really, when we start to look at the platform level in the specific sector, it was this idea of a commercial market that really is driving this. And so as we look to potentially access that commercial market, what are the things that need to be done to ensure that safety and security long term? And as we access that commercial market, what are the key things that we're looking to do? So first, from an access perspective, looking at those technologies out there and looking at those technologies differently than we have in the past, not necessarily with us going and describing the technology that we can imagine, but instead looking at technologies that in many cases are already being pursued, but maybe they're not being pursued, maybe they're not being realized at a speed that's going to provide that long-term competitive advantage. And so to that end, are there places that we can, after we recognize that technology, begin to realize different use cases out there, again, building a market in the early phases, and building a market that starts to recognize where those critical supply chain areas are. And that is where you see from us early engagement with the operator. You've seen this also with NASA in the use cases. And it certainly is part of the work that FAA does when they look at operations. So seeing early engagement with that end user, early engagement in analytics that assess those different markets that are out there, those different types of use cases that are out there. And so that operator piece is key, because if we could have these fantastic technologies, if we can't find ways of absorbing those technologies into revenue generating ConOps, into concepts of operation that provide operational utility, operational agility, then we're not necessarily going to, I think, drive in a way that is necessary the interest in building out that resilient supply chain. So as we look to do that, we see a huge importance in understanding more deeply this transition, whether it be model-based systems engineering that relies on some of the digital engineering, so that we're able to do experimentation early in those different use cases. And then eventually there's those last part. So we've talked first to the technology, the second piece to the concept, and this third piece, this operationalization, this transition of these into larger programs that eventually grow both for a commercial sector use and a military sector use. And certainly a series of instances in the small UAS industry where we might have found opportunity to bring that realization, that operational use earlier, to bring that market earlier, to bring that market across a broader government sector, so that very quickly you're creating this flywheel of activity that spends out a growth in that supply chain that maybe we haven't seen in previous times. And so I think this collaboration that you see here certainly gives some opportunity to do that. And those three pieces across technology access through partnerships with non-traditional firms that are out there in the commercial sector, the deliberate engagement of our operators early in understanding how to do that technology, and then some very deliberate activity that allow us to think differently potentially about our airworthiness. So just as a bit of an update in Agility Prime activities, just over the last couple of weeks, we have internal to the Air Force Airworthiness Office, this is our head for all the flying that we do in the Air Force, identified a path where we now have a means of doing airworthiness with the Air Force for electric vertical takeoff and landing. And so now we start to go, again, as Mike mentioned, in conjunction with the FAA, exploring now some of these early companies in close partnership with these early companies who intend to start flying with us in the Air Force in the not so distant future. As we've taken an approach with Agility Prime, looking at how we remove some of those barriers, we certainly, as we look into the future, realize that taking these early companies is great. We may be able to go and identify some concepts, maybe even be able to bring a small number of them into operations. And that's our intent, is to field some subset of aircraft by 2023 as we start to demonstrate this capability in eVTOL. But if we start to look out into the future and the promise that this particular industry brings, if we do not have a depth across that supply chain that's going to allow not just some of the early cases, right? We're not going to get the economies of scale in the early phases. And in many cases, if we're just looking to fly around, we've got all kinds of aircraft that fly around right now. The promise of electric vertical takeoff and landing with reduced operations and maintenance costs, with the economies of scale that go to developing, designing, and manufacturing aircraft on a scale akin to the automobile industry, to the savings that come from a reduced personnel cost when you get to the types of autonomy that we're looking at, the reductions in acoustics that are necessary. If we're going to realize any of those things, fundamental to that is work that must happen today in the supply chain. And again, the vision that PK has had here to push this forward, and our 100% commitment in the Department of Defense to begin working through these supply chain challenges is something you're going to see more and more of. Some of the specific cases where we're already looking to do this, you've seen on the Agility Prime, if you go to agilityprime.com, at least a beginning to recognize what are the different types of technologies that are out there, and identifying some of the companies that are interested in actually showcasing those technologies in this NASA and Agility Prime online webpage, this ecosystem as we're calling it, to begin at least recognizing what are those different sectors that are out there that need some attention. And then eventually starting to get to some of the analytics capabilities to see the depth of those supply chains, in some cases the depth, even going down, where are there cases where raw materials. When we look across the spectrum of technologies that we see, whether it be autonomy, looking at advanced aircraft and materials, some of the technologies necessary for future acoustics, eventually some command and control, so the microelectronics that are necessary there, as well as the networks, the communications that are needed, apertures, creating alternative waveforms, creating secure communication back and forth, and then clearly the electrical power, the electrical storage, all areas of interest that we have put out back in the 10th of July. We sent that out as a solicitation for a small business technology transfer program. We have received over 300 different responses for those proposals, and a way to start to build awareness among the universities, among the research organizations of the different areas that we're pursuing. So this is, we are certainly trying to launch these efforts immediately, looking at multiple different tiers as we're doing that, making sure that we can in the early stages through some of the model-based systems engineering, through some of the digital engineering efforts that we actually have on contract with some of the companies right now, accelerating that, finding ways that we're sharing across the FAA, across NASA, across the interagency partners, making sure we're doing that only when it is at the understanding and the request of the industry partners that we're working with, and then making sure that we are continuing this collaboration, looking near term at funding opportunities with NASA in order to get some of the analytics that are needed in order to support this and identify gaps that are there. So it's a pleasure to have the opportunity to participate in this partnership with NASA, with FAA, with industry, with some of the investors that are out there looking to get the resiliency back into our supply chain. Looking forward to continuing that collaboration through multiple different sectors, through the larger AFWERX program that we have recently launched, but in particular through the Agility Prime program, and finding ways that we're not just talking about this, but we're taking very near-term substantive action to move this forward. And you've seen that. Many thanks to PK for launching that today. Many thanks to PK for letting us participate, and looking forward to the ongoing partnership. PK, back to you. Thanks so much.
Thank you, Colonel. This is great comments, and we really appreciate your leadership as well as the collaboration to make this ecosystem work. Thank you, and also co-hosting and having a co-lead from the DoD. So, Dana, can you please go online? Thank you. So, all right, Dana. So let's start with some fun exercise. We have a little bit of a briefing here, but let's start off with you're looking good, by the way. I wish I would be wearing ties.
I still remember how to tie it.
I haven't worn a tie since we got on shut down here. But tell us how you got involved in the supply chain. You have a fabulous background. You got a Stanford master's degree and business school, obviously. So you got a lot of credentials, and I'm sure you've taken courses and aced them. But how did you get involved in the whole supply chain thing? And before we kick off this topic.
Well, I mean, my academic training is as an archaeologist, right? So I was working in Peru and Chile for 10 years before I ever even got a productive job. And then I went to work on Wall Street for another 10 years trading equity derivatives in New York. Again, nothing to do with supply chain. Then I was in the diplomatic corps for 8 years with the State Department and traveled around for that. And then I joined, the working world here in Washington, D.C. and, immediately became fascinated with emerging technology, particularly foreign investment in emerging technology. So I worked with in the Committee on Foreign Investment in the United States, which had us really start thinking about kind of where are we vulnerable to nefarious foreign investment. And so that's what really got me thinking about emerging technology. And so now I'm a senior analyst at the Air Force's Office of Commercial and Economic Analysis. Although in a de facto sense, I pretty much work for Colonel Diller over at AFWERX, looking at the same things you are, the supply chain issue. And, it's really an opportunity because we're getting to it early, right? And some of the decisions you have to make, if you want to stand up a new pre-preg line for, carbon reinforced composites, and you want it to be running in 5 years, you got to start breaking ground now, right? And so in some ways we're identifying, or you stand up a microelectronics foundry, good luck. That's a 10-year endeavor. So we're really starting to identify those things and trying to spur investment, because by the time we recognize it in practice, it'll be too late. Right. So we're going to need to, and we don't want the industry to be held back. Right. This industry is growing so quickly, that we don't want it to get the wind knocked out of it. Right. To get suffocated by the fact that it can't get a hold of the parts that it needs or the components. So, that's why it's really an honor to work with you, PK, and NASA and AFWERX and across the interagency. Couldn't be more excited to get involved. One thing I would add, though, when we're talking about supply chain, and I promise I won't say the word robust, we think about it in terms of, can we get the parts that we need? Is the technology there? But another thing to consider is, when you optimize the supply chain, first of all, we want to be sure that it's resilient. I think we've learned that recently the hard way, that it's not all about cost. There's also some resiliency factor in there. But to the extent that you can optimize supply chain, you also bring cost way down, right? And that's the main thing here. At the end of the day, these concept drawings and these these industry players, they're businesses, right? The idea here is that they make money. And so driving down cost is going to be a huge component of that. So, we might talk about it from a national security standpoint or from an emerging technology standpoint, because, it's fascinating stuff to look at, and it brings out the kind of giddy 10-year-old kid in me. But at the end of the day, this is about economics, right? And so the supply chain is going to be, optimizing for that economic cost. And so that's, if you're if you're an aspiring member of the supply chain or an OEM, you know, another reason you want to participate with us is because, you know, we can probably help cut your cost. And that's at the end of the day, what I think is going to make or break the industry, that aside from the regulatory piece too. Anyway, that's just my opening thoughts.
Yeah, thank you, Dana, for that. I appreciate that. It's interesting you say that because I am teaching right now a supply chain management course at business school online, and the topic for this week was coordination across number of supply chain activities. And one of the students, of course, had a very good, nice, astute observation, which we teach in a different way. But the student put it together nicely, saying that different organizations and their effectiveness really is only as good as their supply chains are coordinated tightly, particularly in a very competitive environment. So in aerospace, it's actually a lot of pre-competitive things happen, and because of the tier system and number of suppliers. So there's a huge opportunity for the entire aerospace ecosystem to have this streamlined supply chain that some other companies have figured out or are better than aerospace in general. So we'll talk a little bit about that as we go along. But let's load up our presentation here, and then we go through what we are doing right now, and then what we aspire to do in the next few months. So thank you. Let's see. Okay, so the first slide, we already introduced ourselves. I'm PK. I'm director of NASA Aeronautics Research Institute, and Dana, my great colleague friend, is a senior policy analyst at DoD Agility Prime and Office of Commercial and Economic Analysis. And our contact information is here. I've been keeping up with the questions and moderating basically a lot of questions, how small, medium, large companies can participate, and I'm going to tell you how. You will be pleased to know how we are going to do this, you know, through electronic exchange platform that allows your businesses to be connected with other businesses, other suppliers, and OEMs and such. So you just bear with us. We'll tell you how exactly you participate in this. Next slide, please. So we heard you. We heard you loud and clear. There is not a week goes by without talking to OEM or a supplier that is complaining about lack of resiliency of supply chain. You know, when I studied supply chain, my background is manufacturing engineer a long time ago. We used to call production planning and control, and then it got production systems. And when it became also a capability tool methods for service or industry, then it translated slowly towards supply chain. And it's really critical that we have a very, very strong, resilient supply chain right from the beginning, from design, prototyping, batch production, and small production, as well as mass production, and then towards the end, maintenance, repair, operations. So this whole life cycle of system design has to have a strong supply chain, and different stages require different things, different supply chain aspects, and we'll talk about those as we go along throughout the next few months. But there are significant challenges right now associated with finding suppliers, particularly on early design stages. They're either too expensive, or they're busy with something else, or not able to commit to the time. All of those actually tell one thing, which is that our supply chain for that part is weak. There are challenges associated to find local suppliers to support the drone industry. Drone industry, on one hand, is sort of asymmetric, and one or two significant drone makers, but there are many others who don't have a strong supply chain, and we really need to help that. On top of that, we have new vehicles coming: electric, hybrid, hydrogen, vertical takeoff landing vehicles, and eventually, as other NASA executives said, supersonic and subsonic different types of vehicles. All of them are going to require a significant supply chain. And we heard you loud and clear. I feel your pain. We feel your pain. We really need to do better, and I think we can. And this is the beginning of that. So let's go to the next slide, please. So go to the next slide. So let's talk about the needs of resilient supply chain in manufacturing. In general, when we talk about supply chain, just to ground, I'm sure everybody knows about this. This is a somewhat textbook information. Supply chain consists of all parties, whether they are directly or indirectly involved in fulfilling from demand, forecasting, design to customer need. Aerospace supply chain is completely an ecosystem of different supplier tiers. Supply chain evolved into tiers because one big company did not want to talk to all the suppliers all the time. You know, there are in some cases millions of suppliers for larger type of vehicles. So the tier system evolved as a natural progression to streamline the coordination and such. It's got its own pluses and minuses, but that tier system right now doesn't exist for drones, doesn't exist for vertical takeoff and landing vehicles. So we are trying to figure out how to build that would be nice, efficient, and such. We'll talk more about that. Our focus of that tier system will be one of the months of conversation and distilling down and nailing down basically the right tiers, light level, or horizontal and vertical system. That includes everybody, manufacturers, suppliers, transporters. There were a bunch of questions already on, can the small manufacturers participate? Can the small suppliers, large suppliers, medium-sized suppliers? Yes, you can participate in our work here. We will show you the electronic exchange platform that we are building together with DoD and Commerce, how you can participate. And FAA will also is able to guide us in that based on their certification requirements and the things that need. So we are working together to try to give you the access to the information of each other. Many times people say, I don't know where to go find our molding part maker, and our molding part maker says, I don't know who needs my services, right? So this is a big issue, and we need to, as Colonel Dillon was saying, digitize this, so digital engineering, model-based engineering, as well as this electronic exchange platform, where real issues, real transactions of design trades happen. If you talk to Apple, Tim Cook, one of the finest supply chain experts, you know, who also has a home office in Cupertino, just like me. We just have a slight difference in our bank balance. But that aside, he talks about, you know, basically going to suppliers and working with suppliers as not designed in Cupertino and thrown in some other country and they produce. It's really a very collaborative effort where the design and the manufacturing folks work together to optimize not just for the experience, but also for the manufacturability, also for the design and such. So there's a lot more iterative things that happen, and all those are better done through this platform that we talk about. Supply chain is really, management is coordination of all those activities to streamline that. As we mentioned, supply chain strength and the coordination is really an interesting way to do that. And that gives you the highest possible efficiency. For those who are interested in it, there is a very classical, actually, beer case study that we teach in classes. You know, how the supply chain demand and the delays in some cases fluctuate, and how there's a bullwhip effect and gets cascaded into it, and sort of very interesting case study of it's called beer supply chain case study. So if you are interested, take a look at it online. Next slide, please. So supply chain impacts the entire life cycle, right from the conceptual design. I heard many things, and some of the RFI responses actually have said that clearly, that I'm having trouble finding suppliers in the design stage, or they're too expensive, or we had to wait for a long time, and we can't do that if our process takes too much time. Then you are losing the competitive advantage for the entire ecosystem. So I think we need to make sure that the cycle time is as small as possible, the production rates are as high as possible. So that it really all phases from design to final production, maintenance, repair, and that also includes the skills and talents. You know, a lot of people say, I can't find enough engineers. They steal from each other. Yes, the good engineers, yeah, of course, they're always in high demand, but we don't have enough because we keep the same people going back and forth in different companies, and that can be done better. We need to get better training. That's just not for engineers. That also applies for maintenance technicians. We hear that high voltage technicians who can work on high voltage systems are very much in demand. We can't find them, so for maintenance, for repairs, for assembly and all that. So a lot of that needs to change, and we are taking steps, as John Montgomery said, starting with our minority university research and education program is small baby step, but there's more to be done there. Next slide, please. So it's the basic statistics. We got Boeing and Airbus roughly producing 1,600 per year. This is pre-COVID, obviously. General aviation, roughly 2,000 per year. Rotorcraft, roughly 1,000. Cars and worldwide are about 70 million per year, and in the US it's 2.8. And of course, there are dreams that the advanced air mobility vehicles, as well as some of the drones, they could replace some of these cars, and they would need high production. So a lot of postulations happen. There's 10% of these could be replaced by vertical takeoff and landing of different types, whether it's electric, hydrogen, hybrid, or whatever have you, as well as drones for cargo operations and such. Well, that's a big number if you compare with what the current production cycles are and rates are. So that's nowhere comparison to that. So we had to have a different supply chain, or the way we coordinate is different. The way the new entrants need to come inside the supply chain so that we can allow them to have this rate and scale and turn around processes faster. So you can just see the scale that's possible here to change the dynamics and the huge business opportunity for suppliers to come in. Next slide, please. So again, this kind of validates the need. I've been obsessed about this because, as I mentioned, I teach. I had my basic training in this thing, and then eventually, it dawned on me that I had to practice what I preach in the classes. Really, it took some time in the last couple of years. I said, okay, I got it. We got to do something different here. Just like my other passion on aerospace, 6 years ago, we started to unmanned aircraft system traffic management for scalability. This is a similar thing, but it's scalability of production and scalability of basically operations. So I had many calls, texts, interactions with OEMs and tier suppliers, looking for suppliers, manufacturers for actuators, motors, propellers, castings, over-molding parts, and forging, and then mold forming. Mold forming used to be one of my favorite subjects when I was doing manufacturing training, when I worked in a bunch of manufacturing companies. So many of these parts and manufacturing needs are unmet, and that can continue to happen if we want to see the scale that I showed you in the last slide, in terms of the aerospace healthiness and manufacturing. So we really need suppliers for the entire life cycle. Great opportunity for you all, industry, to be part of this and build this ecosystem, be part of the supply chain, offer services to OEMs and the tier up suppliers, all the way to the raw material. There are issues with cobalt and tungsten and all those things, and there are design trades you have to make based on. We'll talk a little bit about that as well. Next slide, please. So current challenges, obviously we want faster cycle time and faster production rates. That's been the need of aerospace industry forever. Usually modern aircraft, all of them are overweight, over budget, and take too long. So that kind of stuff can continue to happen. We had to change the dynamics, and in order to do that, we need to focus on these metrics, key metrics: cycle time, production rate, and design assurance and production assurance, which FAA fondly really cares about that. So there are a number of challenges. We talked to OEMs, and I had talked to many OEMs and suppliers: casting, forging, composites, auxiliary power units, printed circuit boards, actuators, software, methods for assembling them, and many other challenges exist. Microelectronics for avionics, all of those. These are all fundamental challenges that we have. But those challenges can be turned into opportunities, because these are our opportunities to change and build them. And if you build it, there is a demand for it. And I think we will help you. All government is going to come together. Unfortunately, the Department of Commerce folks were not available today because they had another event and commitment, but they will be next time around and onwards. So this is something that we deeply care. We care about it, this from the perspective of a healthy aerospace industry. So we need to change this dynamic, and that let's look at these challenges as opportunities for us to make impact. How can we generate momentum? How can we generate businesses in these areas because there is a demand? Next slide, please. Some of the known supply chain related issues: sourcing of raw material, aluminum, steel, copper, standard ones, but also tungsten and many other, titanium, cobalt, all of those. Mitigating supply chain disruption risks. There are a lot of geopolitical considerations. Of course, there are some black swan events like COVID that we all have seen. Also, coping up with modernization, emerging technologies. There have been examples of wiring, software, lavatories not being available for business class. Those are all examples of basically lack of a healthy supply chain. There are shortage of skilled workers, and that's one of the reasons why Tim Cook says he does outsourcing, not just the labor cost, but it's just pure shortage, and then having access to the healthy and deep supply chain. Those are the kinds of things we've seen. We've seen, one or two bottlenecks, sole sourcing and such. And those can continue to happen. We talk to many companies. They talk about basically very few suppliers and for ball bearing and some few other parts that are confidential for their own businesses. But it's critical that we have healthy supplier base for critical parts and such. Let's go to the next slide. So typically, supply chain strategies are many suppliers, few suppliers, vertical integration, joint ventures, which you see these days, horizontal integration, Keiretsu networks, another really interesting Japanese way of doing things, or collaboration and supply chain, and sort of hybrid of different things, and virtual companies. And what I have seen right now is for majority of the drones as well as VTOL companies of all types, they are doing vertical integration because they are trying to control their IP. They're experimenting, so they don't really have a lot of access to supply, and then they don't have access to suppliers like quick turnaround. So they're doing a lot of things inside vertical integration. While that protects your IP, that is not necessarily a scalable solution. You have to have a healthy tiered supply chain so that you can continue to innovate on parts that you care the most, not on every detail. If you have to build everything vertically, it's a very complicated process, time consuming. You can't innovate on every subsystem that gets integrated. There is a significant level of disadvantage of having vertical integration as you switch from design to batch production to mass production. Vertical integration looks less and less appealing and more risky. So right now that's okay till they finalize their design and such, but even then they need a lot of other suppliers, materials and structures. I mean, there is already interesting case study of Ford, who wanted to control the quality so much that they were obsessed about. Basically, they invested in plantations, rubber plantations to control the quality of tires, and they realized that's just not possible. You cannot vertically integrate to that level where you had to manage the plantations and people and staffing and resourcing. It became onerous to their primary business. So they gave up on that idea very quickly. So that's the example of extreme vertical integration, which doesn't work. So we really need to have this right balance. Some of the key things you may want to do inside, but there is others that you can do through your supplier network, and that's what we want to build here with you all. Next slide. So how do we do this? So what are the recommendations? What are we going to do? So we'll focus initially our MVPs, minimum viable products, although we care deeply about all of the aero types of vehicles, everything, hypersonic, supersonic, subsonic, drones, VTOLs, space, all of that. And we'll get there, but right now we're going to start with minimum viable products that are focused on VTOL, and there was a comment, and I agree with the comment, that it shouldn't be only electric, it could be hybrid, it could be hydrogen, and so on and so forth. So point well taken. The vertical takeoff and landing types of vehicles and drones, both are going to be our first focus. Drones, folks, and I deeply care about them because the unmanned aircraft system traffic management work I did in collaboration with industry, that industry also needs a vibrant supply chain, same as VTOL industry. So we really need to start building new supply chain, new ecosystem. We have learned through ventilator examples that going back to the same suppliers, you are only limiting yourself. Sometimes you need to think of your design and in terms of materials and moving parts and all those things so that you can take advantage of available access to other supply chain. Want to focus, sorry about that, all manufacturing capabilities, not just a conventional aero, but there are a lot of manufacturing out there that it's train or auto or heavy industry, in addition to the traditional aerospace industry that can see this as an opportunity space. A lot of regional manufacturing supply chain associations expose them this opportunity space, bring them on board. They can advocate for inside their own states and regions how this can be supported, generate jobs, generate businesses. We already have a number of manufacturing associations and number of states joined in through the RFI. So I'm very grateful for that and looking forward to continue to do that. I think it's a great opportunity for everybody, including some of the foreign global suppliers. Next slide, please. So we are going to build a modeling simulation platform that will analyze the capacity and allow us to do parametric studies of different scale. What if I need 100 per month? What if I need 1,000? What if I need 10,000? Do I have enough capacity for actuators, ball bearings, avionics? Where am I falling short? What are the gaps? Where is the resiliency missing? Are all my suppliers located in earthquake part? Or are all of them located in tornado alley? How do I diversify? How do you make sure that there is a clean resiliency involved? So everything, scale, cycle time, resiliency, gap analysis. So we don't have any baseline right now. We don't have any benchmark. So we are building the modeling simulation, kicking off. We have joined DOD and FAA, and now we're going to bring, DOD and NASA, and we're going to bring FAA as well as Commerce into this for this simulation capability. It's going to be something that we will be able to analyze the need and parametrics related to future and different scenarios, as John Montgomery was saying. We are building electronic exchange platform that will connect the VTOL customers and suppliers with each other for every stage, from design, job production, mass production. And then FAA, we will be working with them for their quality management. They have this know-how and they are the regulatory experts. So we want to bring that level, basically, richness into this. So again, it's a really tight collaboration with DOD and Commerce, FAA, and NASA. We will establish, working with you, a tier system. What is the right tier network, horizontal and vertical? What is the right trade-off? MRO network. MRO is essential if you want to, because these operations will occur at the local level. So how do we make sure that locally they are ready for maintenance? You have the technicians, you have the part inventory. Those are authenticated parts. There are a lot of interesting things. Just like your car, you go to the local shop and get it checked to get your maintenance. And we will need that. We need to set up that for VTOLs as well as drones eventually. We also need to train the workforce in terms of different curriculum, skills, and entrepreneurs who will lead these businesses at the local level, and production and manufacturing and supply logistics, as well as MRO. Lots of great opportunities. Next slide, please. So what we are launching today is this work group that is going to be supported all government, NASA, DoD, FAA, Commerce, which want to help the industry's urgent needs for drones and VTOLs. We want to build a tier system that will be one of our next big deliverables coming out of the work group. That's a critical need. That's key to efficiency. This network tiers is going to keep the efficiency to the highest. So we had to build it in that in mind, resiliency and efficiency. Then this modeling simulation platform, working with everybody to make sure that we assess the gaps. Where are the needs? Where we have sole sources or single sources or very few sources, actuators or ball bearings or motors or batteries, microelectronics, you name it. We will be looking at all of those aspects. And then this electronic exchange platform that facilitates frictionless or reduce the friction for transaction from design to manufacturing, as well as rate and collaborate with each other. Right now, people don't know where the suppliers are. Suppliers don't know where the demand is, and that can be reduced by this electronic exchange platform. We already have a great now response through Agility Prime, as Dana said, initiative of ecosystem, and then what we put as an RFI. So we will be working closely with Agility Prime in building that. We are completely open to your suggestions, other suggestions that are of important to you. Tell us what is needed for industry, and we want to help get there. We really want to work with you to prepare for the future so that we will have scalable, resilient supply chain for drones and right now eVTOLs, but I will expand that next time to just electric, hybrid, and other types of hydrogen and such. So it's VTOLs, just take that as VTOLs and drones. Next slide, please. So that's what we're launching today. It's a really fabulous day. It's a dream for me personally, to see this go together as a collaboration. So our future meetings, September 10th, we are going to start talking about the real nitty-gritty issues that you guys have. And we will give a talk on saying this is what we understand challenges are for drones and VTOLs, and what you can tell us if that's your feeling, and there are other challenges. And by the way, a week before you can start to populate the conference IO, we'll make those announcements. And at the bottom of this slide, you will see that you can send comments. You can basically offer feedback, any comments on these types of topics we have or anything. Tier system, that's the second thing we're going to do. We're also going to identify where standardization is useful, where it's not. Dana makes this point. You go to gas station and you have one nozzle that works with every car. We could have standardized nozzles for charging. There's no reason why you need to have a very restricted IP charging, because the less we do that in some cases, or we standardize in some cases, the cost will be lower and ease will be higher. So there are places where you will protect your IP. We know that for sure. There are places where we could all benefit from standardization. So where are those pieces? Let's identify those. Let's figure out how to make that. Electronic exchange platform, let's get that going. We are requirements, building it. We have the right talent put on both platform and modeling simulation. And they're connected, by the way. Modeling simulation is as rich as the platform tells in terms of who the suppliers are, what the parts of the tiers are, and what their capacities are, where their shortfalls are. So we can actually do these models and assessments and parametric analysis for finding gaps through various scenarios. This platform is key to that. Next slide, please. So that's the end, basically, and we're kicking this off. Dana and I are really happy to kick this off today, and you will see many topics come up as we go along in the future. But we definitely want to hear from you, and if there are other topics of interest, this is clearly, we're not stopping in January 14. This will continue past. These are some of the initial topics we put out, but our goal is to get to that platform, make that platform operational, make that modeling simulation environment operational, start to analyze the ecosystem and figure out where the gaps are, where do we need it to focus on building up manufacturing and supply chain capabilities, where are we sole source, single source, reduced, the kind of focus. And I talk to many companies, large companies, small companies, and these two kind of keep bubbling up in terms of the three, including the talent. So they bubble up as the primary things that we really need to tackle, but we are very, very much happy to also look at other aspects. So with that, I'll stop. And Dana, would you like to add other things?
Well, first of all, that was excellent. And I'm as excited as you are. Maybe not as excited as you are, but pretty close. I don't know if anyone could be as excited as you are about I will say, this is an issue that we can't afford to just sit back and admire the problem. Right? I mean, this is something we're going to have to cope with, and we are putting real resources into it, right? We've got people, we've got, funding to some degree. And, I read a couple weeks ago that between 30 and 40% of the entire aerospace workforce is going to be eligible to retire in the next 5 years. So we've got a shortage as it is, and it's only going to get worse unless we address that workforce challenge. Now, that is a more sort of long-term issue, and there's policy behind it that might need to change. But realistically, if there's no one to maintain these things and fly them and build them, we're going to come off flat-footed right from the get-go. So it shouldn't be a problem right out the door because the scale won't be big, but it certainly will be a limiting factor if we do want to scale and operate at the levels that the Ubers of the world are projecting. So and I also wanted to reiterate the other piece, which is the local aspect. Different localities, different municipalities have different sets of motivations for wanting to be involved in the eVTOL world, right? Some because of congestion, some because their landscape is bifurcated by water, and it's easier to fly over it than it is to build big expensive bridges or ferry service. And some are forward-leaning from a tech standpoint. Some are going to be more resistant. And so one of the things we're seeing already is that certain municipalities are leaning into this more than others, right? And so I think initially the use of these vehicles and the requirement for the vehicles is going to be very much tied to the landscapes politically and naturally over which the vehicles are going to fly. So I think we'll look for it to be at first a very local phenomenon, right? And the areas with amenable political leadership and regulators are going to be the places that we see these things flying first. I don't think they're just going to burst out all over the country right out of the gate, right? So that's just to reiterate what PK was saying earlier about the need to involve local authorities and localities in our ecosystem, because they're going to be key enablers just the way the battery people are or the propulsion people are. So so with that, PK, that was an excellent presentation. I guess next up we're going to maybe look at some Q&A.
Absolutely. Let's look at some question and answers. I have been trying to keep up with some of the question and answers, moderating them or responding generally, but let's take Q&A. So Anna and Brianne, how do you like to take questions? Do you think we should take it from directly from Conference.io? Is there a better way to do it?
Yeah, PK, I would just go directly through Conferences.io. If there's specific questions you would like to ask, I'd say, or answer or talk with Dana about, I'd say start there. Otherwise, Bree and I can read off the questions that you have not had a chance to answer yet.
Yeah, so let's start from the top. Go ahead if you want to take them on, or you want me to read them, Anna?
Sure, I'll go for it. So
yeah.
The highest voted question is, are companies outside of the United States but with prior DoD experience able to participate?
I mean, the short answer is yes. I mean, I think we are amenable. I mean, it will depend on the country and what exactly they're contributing. So it'll be contextual, but I think broadly speaking, of course, we're open to cooperating with international partners. I mean, we may be a little more limited in our ability to do things like, say, put in SBIR funding or things like that, or kind of the federal government regulations around businesses needing to be U.S. for some of those cases. But for the purposes of the ecosystem and the development of eVTOL as an industry, I think we would welcome collaboration from just about anywhere.
Awesome.
Perfect. So the next question, I think this one's more geared to you, PK, is would it be possible to get a copy and be involved with NASA's Advanced Composites program?
Yeah, and I think the short answer is yes. We will definitely introduce you to the project manager and the team that is doing the composite program. It's a very exciting program, and we will be more than happy to do that. As Dr. Jimmy Kenyon introduced that and showed the importance. Yeah, just ask, please, if they don't mind, whoever asked the question or those who are interested in it, send an email to me or to our general email address we showed, and we'll be happy to connect you. That's thank you for your interest in that.
Yeah, I was glad to see. I didn't realize NASA was doing that. I mean, that's a very important enabling technology. I know, some of the firms, the U.S.-based firms that are doing a lot of composites work now are investing heavily in scaling up their ability to meet the need for eVTOL. Which I applaud. There's some really good work going on in the state of Utah around, kind of the composites industry and how it can respond. And so, yeah, to the extent that we can accelerate the production and volume of composites production, and particularly looking at processes, out of autoclave processes that don't have such a big capital requirement, that's going to be all the better. So I really applaud the fact that NASA is doing that and fully plan to track that myself.
Thank you, Dana. So the next question is, most supply chain challenges can be tackled at the product development side. What role could engineering firms play?
Yeah, so this is what we have learned from other operators, as well as some of the big OEMs, is the give and take in the design and the manufacturing is critical. And this is why we're building this platform that allows not just to set up the supply chain ecosystem and such, but also do these design trades and this kind of digital engineering, as Nathan was talking about. Yeah, so they will have a significant role. They should be part of this exchange platform as well, to coordinate their designs with the would-be suppliers and would-be suppliers to offer sort of ideas. And this is the whole point of concurrent engineering, concurrent manufacturing. So, yeah, they should definitely be part of this. I think the platform is a right place for them to be there.
Perfect. So I'm going to move down the list a little bit, but one question is regarding small business. They're saying much focus is on small business. Larger suppliers need to pivot for AAM, and global supply is a characteristic of basic materials. How can global suppliers be involved with a large number of smaller companies that NASA is advancing? Agility Prime ecosystem, other NASA database?
Dana, go ahead.
Well, I mean, first of all, I mean, we're seeing some of the the big guys, the tier 2s, the tier 1s, doubling down on eVTOL. I mean, it's actually very heartening to see new offices being established and new people being brought on board. In this environment, this economic environment, it really speaks to the importance of the industry that these guys are willing to invest heavily in their eVTOL operations at a time when resources are hard to come by and revenue may be falling. So we certainly applaud the larger firms investing in it, but at the same time, one of the things that we're trying to emphasize, I think, and maybe you can chime in here too, PK, but we want the supply chain to be competitive, right? Competition is good, right? It's going to lower prices, it's going to speed innovation. And so, we definitely want to foster the development of these smaller kind of startups, because, they're going to help maintain competitive pressure, maybe on some of the big guys that are already in place and have, more resources to throw around. And that's not to disparage them at all. I mean, this is just part of how you get good at things and how you optimize is to have a competitive sort of atmosphere. So we're certainly motivated to foster the growth of those smaller firms. I think the question is just going to be kind of where are you in your technological readiness level? You know, which programs? I mean, again, SBIR or STTR administered through AFWorks. I mean, we're very actively pursuing proposals for those programs and writing checks, right? So I think that would be the earliest entry point. I mean, certainly participate in the Agility Prime ecosystem, but at this point, it is a little difficult for Agility Prime per se to invest or help your firm because we're more focused at this point on the OEMs that are flying vehicles, and you know, it could be in subsequent iterations we start to be able to look, you know, into the suppliers a little more. But I think for the time being, for us, it's primarily going to be done through SBIR, I would guess. PK, do you have a NASA perspective?
Yeah, so I think that those are good, SBIR, STTR, but also being part of the exchange will get them access. I think it's really what we are really trying to do is reduce the friction for would-be suppliers to find each other, as well as the lower tiers to find upper tiers to find lower tiers, and they to find the OEMs. And the time it takes and the transaction time it takes right now because of the lack of digitization in some cases, not always. In some of the OEMs have their own network, niche network of through digital things, but we don't have a wider network for drones and VTOLs. So we would like you to encourage to be part of that, so that once you are in the network, then people know who you are, where you are, what your capacities are, what you're capable of manufacturing, whether you are small, whether you target on the design side, whether you target in the production side, mass volume. You're able to do that. You're able to send information about your capabilities and such, and other people are able to find you. This will grow in economies of scale. You know, first it will have 100, then it could have thousands, and then many thousand suppliers would be on this platform that's focused on aero needs, and then that allows us to do assessment of the gaps, and then we can do feedback loop and saying, hey, we still have gaps in ball bearing or actuators or batteries, or we don't have enough capacity. You know, those kind of things are, I think, only possible if we are all in the network, and this is a very powerful tool because it reduces friction to find your would-be customers as well as would-be, next step of collaborators. So absolutely. And by the way, access to capital. And we are going to, I mean, this will be very powerful tool for investors.
Yeah, it certainly would be good to see more. I mean, I understand that the kind of the venture time horizon may not harmonize exactly with the time horizons we're talking about with eVTOL. But I certainly think there are other capital providers out there in addition to VC, and we'd love to see more of you in the ecosystem. And the other thing I would add is, our plan is that the ecosystem not be static in the sense that, of course, we're adding members, but also engaged in conversations with the membership about kind of where or how we can kind of perform a little bit of due diligence along with you on your capabilities, and the idea would be that at some point we will be able to, the companies that have demonstrated openness and forward thinking and look like they're going to be active members of the industry, we might at some point be able to give you a little gold star or something next to your presence in the ecosystem, just to say that, hey, these guys have been through a little more due diligence and we liked what we saw, right? I mean, that doesn't imply a purchase commitment or anything, but it's just kind of saying we looked at them and they seem like they can do what they say they can do.
Thank you. Yeah, I know if there are. I think there's still some NASA folks on the teams, and they're welcome to offer more thoughts as well. Anybody else from NASA? Let's keep going. I mean, we are obviously, there are a good bit of questions, very nice questions, and there is interest in by different levels of suppliers, which really is a good thing to see for us. And we feel that somewhat of a validation of what we are after. So please bring your questions here or later is just fine, and we don't have to drag on till 10 o'clock Pacific. If we have already answered majority of the big questions, and we will give you a few minutes back. But we want to continue this. The next month is going to be a very good discussion with Commerce, as well as we will have FAA co-lead, and we are going to start to dive into the needs of characterizing the needs better. Next. And I don't know if you want to add another question or two, and we don't certainly have to keep going till the end. We can end early.
Yeah, we just had 3 questions pop in actually, so I think it'd be good to touch on those. One is directed towards Dana and DoD cybersecurity. They're asking, will DoD cybersecurity requirements, CMMC, create enough supply chain friction to discourage participation in this space?
Well, I certainly hope not. I can tell you there is a lot of discussion happening, with Colonel Diller and his team about this concept of trusted microelectronics, right? And particularly as an enabler of autonomy, or potentially something that could significantly slow down our ability to implement autonomy. So we're talking through how, and there are a couple of firms that have done work with DoD before, cyber hardening processors and boards, and also making sure that they're safe from a security standpoint. So I think that we're going to end up exploring that idea of trusted microelectronics quite a bit more in the coming months, and whether or not it warrants a full kind of Agility Prime style treatment, or if it's done more as kind of a spin-off. It's something that we see as being a key. Now, I can't get into the specifics of the DoD cyber requirements just because I don't know them, and I wouldn't want to speak out of turn. But I can tell you that we are certainly looking at, as we talk about moving toward autonomy, these trusted microelectronics are going to be a really hot topic.
Great. So one more question is, what is your MVP vehicle in the next 2 years?
Yeah, that's a great question. I think my answer is the initial exchange platform, which will operationalize at least some parts of tier 1, whether it's battery, whether it's microelectronics, whether it's some other major piece of VTOLs. And we'll have basic of tier system laid out, and then we will have modeling simulation environment to start to do some macroscopic analysis. It won't be rich completely yet, but I think we can start to dissect into some of the critical parts, related things, all the way to take the thread all the way to the raw material. That's sort of our dream, and I think it's doable in a few years, because we are joining forces with resources and ideas and such. So I think it's definitely possible to get there. Dana, do you have any thoughts on that? I mean, these are my views. We haven't really, we're just brainstorming in this.
Well, the modeling and simulation, right, are only going to be as good as the data underneath them, right? And so that's the reason behind the RFI. It's the reason that we've been asking for information when people join the ecosystem. That's not just that's not for advertising purposes. That's because we're going to use that data to drive these models. So I would encourage anyone who is replying to those mechanisms to please be as forthcoming as possible, because it'll give us higher resolution when we run it. The team is just now coming together on the modeling and simulation side. So I mean, once they've had, I think, an initial look at how complete the data is, and if it's sufficient to really drive the model, we'll have that in our back pocket, and maybe we'll have a meeting of this group where we ask for maybe a little more detail, if we need to fill in some gaps in the data to make the model run. But yeah, I agree with you. I think 2 years as a time horizon for the modeling and simulation is pretty good. The ecosystem kind of snapshot, or the digital exchange piece, I think we can do quicker, right? We're getting there now. So stay tuned, because we'll have kind of phases of deliverables. The first one will probably be the ecosystem piece, which I know a lot of you are looking forward to, just because it's, from a practical standpoint, something that you can act on and utilize right away.
Great. Now, I think just the last piece I think would be great before we close it out, PK and Dana, was we have quite a few questions about how people can get involved, whether they're suppliers and how will they be contacted, or universities with like supply chain and modeling experience. How can they get involved with the working group or share their capabilities with you to really help these initiatives? Naturally, I want to say the RFI and going to the NARI AAM supply chain site or emailing our generic email, but what in your minds are other ways that they can really share their interest with both of you?
Yeah, first of all, thank you. Thank you for willingness to share. This is the exact collaboration we're looking for. We do not want to reinvent what is already done, and smart people are there already thinking about different things. Our goal is to reduce friction, not cause more. So great to see that there's some capabilities and databases and things are out there that we can pull together. Yeah, please send us the email with your capability that you like. RFI response is a good step, as Anna mentioned, also that email. And the way we built in the prior systems that included other folks and their competencies and capabilities with, we had API-based systems, so we will expose the APIs that will allow others to connect into it as needed for back and forth exchange of information. We certainly do not want to compete with the commercial entities or duplicate things that people are already doing. No need to do that. It's to really take it to the next level of maturity and next level of analytics as well as operationalization. So yeah, by all means, tell us what you have. That's one way this group will actually help each other, because I think it's a great point that different schools, universities, companies have different capabilities, and when we are not going to take their IP away, we want them to be productive and be part of this so that everybody benefits, because this is a big, complex problem and it requires many, many pieces. So it's always good to have this collaboration. So we would promote that, and we've done that. We have examples of unmanned aircraft system traffic management where we build a core, we build the APIs, we build some analytics and capabilities, then allow others to connect into it. So it really, that model works, and that's a similar model we'll be continuing.
Perfect. And with that, I'll send it to both of you to close out the session or the kickoff.
Thank you so much for Anna Kowalski and Brian Stahl-Smith. That was and Ash Khan and Alina. And Mike Chirides, Chris Clark. There are many, many people who helped. And I'm sure I'm forgetting some, and I apologize for that. But without your tireless work to make this seamless, it wouldn't have happened, in spite of my own problems today with the connections. But it's great. Thank you for your great help. And you guys made a very smooth event, so appreciate that. Dana, very much looking forward to collaboration and industry and academic collaborators. This is a right place. We are going to have a lot of fun. We are going to do real work in work groups and build something together. I'm fascinated. We had to build something together to make a difference. We are going to do it together, and looking forward to that collaboration, friendship with everybody. And we are always open to ideas. Do not be afraid. Be critical. We learn from critics as well. So this is just feel free to share what you have on your mind. Thank you. Dana, any comment?
Oh, I couldn't possibly have said it any better myself. Yeah, just a very exciting time. You know, this is just the kickoff, right? I mean, this is the talking part. You know, when we get into the real meat of it with the kind of topic-driven stuff in the coming months, it's going to get even more interesting. So we hope that we keep you all engaged and involved and excited about this. And I hope our retention rate of membership is as high as it can possibly be, because we're going to be leaning on your brainpower and your insight in the coming months.
And it's going to increase, and we are going to make sure that you get benefit out of it as well.
Yeah.
So it's absolutely something that you will benefit from it. Thank you all. I think we have John Kowalski, NASA executive, still, if he wants to offer any closing remarks.
No, so thank you, PK. Much like Dana just said, I'm not sure I could put a better wrap on this myself. Again, very, very pleased to see this level of interest. It validates our initial concern that there was something in here for NASA and value that we could provide to this. I mean, any of that, I believe, has been completely allayed. And we're just working hard to try to find that right niche, and bringing the community together is certainly one of those. So again, thanks for everything that you've done with Dana and your larger NARI team in the community, FAA, and our other partners. So thank you much. I look forward to continue to track this as time goes on and contribute with the right level of NASA investment. So thank you much.
Thank you, everybody.